Hey guys, I'm Luke. In the intro, I kind of found it funny that Perth was referred to as the arse end of Australia because I was actually born in a tiny town in the wheat belt called Pingelly, which that really is the arse end of town. Um, so I wasn't, I can't really say that I was born in the cloud, but I have actually had the opportunity to fly through the cloud and immerse myself in the cloud. But unfortunately for me, or potentially you guys, that's probably the extent of my qualifications to stand up here. But today I'm just going to talk about a step function I made for Chumba Casino. It was one that takes a snapshot of our production database, sanitizes it, and kind of makes it available in our dev environments for load testing or testing out new features and whatnot. So there's 6 sections. I'll go through them all pretty quick. I don't have much time up here. Probably the bit I'll spend the most time on is the security features. So one of the challenges I set myself when building this was to make this both secure from data exfiltration, but also to stop incompetent developers and engineers, including myself, accidentally doing the wrong thing and accidentally deleting production and that kind of stuff. So you'll get a bit more context on that as we move forward. So in Chumba, one of our biggest performance bottlenecks is jackpots, and that combined with the fact that our database is extremely large because we don't currently have a habit of archiving data from our database. So the tables are quite big, and the jackpot query itself is quite performance sensitive, and so it's important that when we test performance, we're doing so on a production-sized database, because it's one thing obviously to run jackpot queries on a small set of data. It's another thing entirely to run them on production-sized ones. So we had this, I was chatting to Nick Sear, who's one of our engineering leads on the game team, and we were talking about how good it would be if we could kind of just automate that, because manually it's a pretty expensive process. And there's lots of pitfalls. So I'll just take you through what the process was when I first started. Basically, we need, so we're already doing dangerous stuff. We're in the production account, and we need to restore a gigantic database snapshot into a new RDS instance. So those are reasonably quick, but it still takes sort of 30, 40 minutes. And you're clicking around in a pretty scary part of the AWS console, particularly in production when you've got an app that's generating quite a lot of revenue for your company. You don't really want to click the wrong button. So that's already a scary part, and we're on step 1. The process happened pretty ad hoc. It maybe had happened 3, maybe 4 times before I started. But once you had the snapshot restored, you then needed to go and speak to a developer and get the script that they used, because it wasn't in source control. It was kind of just this mishmash of scripts that grabbed, certain table columns, so first names, that kind of stuff, and scrambled it. You then need to figure out a way to actually run that script on your restored RDS database. So generally involved a bastion. We're talking about credentials here. You obviously had to make double sure, triple sure that you didn't accidentally connect to the real production database and run that script, because I would probably die and get killed by our bosses. So that takes sort of 2-3 hours. Next step, once that sanitization process is finished, we then needed to create a snapshot from that new instance, and then we needed to copy that snapshot again. Now, anyone who's played with RDS will probably know that if you create an RDS instance using the default KMS encryption key, you can't then go and share snapshots with other accounts, like your dev account, unless you first create a copy and change the key. So that kind of added another really lengthy, unneeded step in the process. Again, 3 hours, and generally these steps kind of happened in a really kind of disjointed way over a couple of days. So you can imagine there's lots of opportunities to forget about something or potentially forget where you were and make mistakes. And this bit, arguably the most scariest thing you could probably ever do is click the delete button in the RDS console in your production AWS account. You haven't lived until you've done that, so I don't recommend it. Particularly, like I said, if you're a small startup and maybe you've got $50, okay, you might upset a few investors or whatever. But when you're in an established system that's serving hundreds of thousands of customers, yeah, that really puts hair on your chest. So overall, this whole process is about a 5 or 6 hour process. Like I said, sometimes stretched out over 3 days, and it's a huge pain in everyone's neck. So the solution to this was a step function, quite obviously. And there's a couple of reasons I picked the step function service to do this. The first is that they're actually extremely good at orchestrating really long-running processes. But the other, I guess, two things that really interested me in this was one, obviously, the whole process could be done with AWS API calls. It's sort of, restore snapshot, boot up either an EC2 instance or a Fargate task to run a script, snapshot, all that kind of stuff. But because it was so tightly integrated with AWS, there are super tight security controls you can use. And like I said, that was kind of one of the challenges that I threw myself to make this the most secure thing I could and prevent Chumba Casino from being destroyed from the inside, basically. So it took about 9 different Lambda functions. So step functions obviously is just an orchestrator. All the heavy lifting kind of happens in Lambda functions. I made use of Simple Systems Manager to run commands on an EC2 instance. In hindsight, I wish I had have gone down the Fargate task route, but I'll talk about that later. In this case, I went with EC2 because I was most familiar with that. And I managed to create a bunch of airtight security groups, networking rules, and IAM policies to ensure that, again, we didn't sort of destroy Chumba Casino. This would usually be the part where I jump in the console and show you, but again, it's only a short talk, so I'll skip over this and we'll just kind of scan down the export. The basic process, like I said, I've already outlined for you. Find the latest snapshot, restore it. Once it's finished, boot up an EC2 instance, run a script, run the snapshot again because we didn't have foresight to use a customer managed key, and then copy it, share it, all that kind of stuff. You get the idea. But the security features, like I said, this is what I wanted to spend the most time on. There's quite a lot there. I'm not going to go through each of them in detail, but probably the two that I found, I guess, the most satisfying were the networking controls, particularly around the EC2 instance. So it had no outbound internet access at all, thanks to being able to use things like service endpoints. And due to being able to have very granular security groups, it was, it's practically impossible for this EC2 instance to accidentally or on purposely or otherwise to connect to the production database. So I was telling my mum this, she was extremely impressed. She had obviously no friggin' clue what I was talking about, but she loves me and she supports me, so thanks, Mum. Love you too. So here's roughly how I set up the security groups. At first, I was kind of reticent about spinning up this, I guess, temporary RDS instance in the same VPC next to production. But after thinking about it some more and knowing kind of the granular controls you can put on security groups, I figured it wasn't a massive risk. I think if I had more time, I probably would have spun up a separate isolated VPC. But this is what we went with to start with. As you can see, the EC2 security group has no inbound rules. If I ever needed to get on that box to troubleshoot something, I would use Systems Manager Session Manager to get a shell open. And the outbound rules only allow some very specific things. Obviously, connection to the RDS database, and HTTP and HTTPS to the S3 gateway endpoints and the service endpoints. So it can still communicate to AWS services, but not have to traverse the internet. So as a result, you can only talk to the temporary instance, and there's kind of no way for it to really impact anything else that's running in that VPC. The RDS instance has 0 outbound rules, meaning it can't initiate a connection, and the only inbound rule is, again, from that very specific security group those temporary EC2 instances get set up. So it's even impossible for existing services, even if they have very open, unrestricted outbound access on those groups, they can't talk to this temporary RDS instance. So this is just a quick skim through some of the IAM policies. So as a lot of you guys will already know, trying to secure describe actions is kind of hard, but it's also not really a huge problem. Generally, if you're running describe in the AWS account, you don't really mind if they see the names or are able to enumerate stuff. Obviously, the big ones we really wanted to control were things like access to the S3 bucket where the script was stored. We don't want the EC2 instance to be able to download just any arbitrary S3 script from any arbitrary S3 bucket. It's only allowed to talk to very specific CloudWatch log groups. This is all reasonably standard stuff. The last one there is, so we obviously needed to reset the root password once we'd restored the database, and we needed to store that password securely. That's in Secrets Manager, and because that password is regenerated on every restore, we needed to find a way to be able to restrict that get secret value action without knowing what the full ARN or the name of that secret would be, and we do that with the resource tags. And we do a very similar thing with some of the other actions. So again, the top describe stuff is kind of hard to secure, but it's not a problem. On line 29 there, you can see that we are restricting Lambda from restoring a snapshot unless it tags that restored instance with a particular tag. And then this lets us follow up with the big scary actions we need to secure, like delete DB instance, modify DB instance, and that kind of thing. And again, restrict that with an AWS tag that we know in advance. So on line 51 and 52, unfortunately, those particular actions don't support many of those condition keys, so we were kind of a little bit restricted in how we restricted those, but it wasn't a massive problem. We obviously allow access to the relevant KMS keys. And the last bit there allows Lambda to create an EC2 instance, but only one based on a launch template that we'd obviously create in advance. So it can't just spin up any arbitrary EC2 instance with any arbitrary AMI to run malicious code in our VPC. It's all very controlled and restricted. And finally, pass roll is probably one of the most dangerous actions you can really have in your AWS account. Generally, out of the box, when you just allow it, it kind of allows very trivial privilege escalation. So we restrict that to only a particular role, again, that we've generated in advance. And we also only let it pass roles to the EC2 service itself to limit what it can do. And again, more similar stuff like we've spoken to before. So it can only terminate instances with the relevant tag that were also launched from that same launch template, et cetera, et cetera. So yeah, it works really well. I was pretty proud of it. Made sure to definitely mention that at salary review time, because it actually is the most secure system we've got in Chumba Casino. So yeah, Reese, I'm looking for a pay bump, by the way. So now I'll just walk through some of the pain points I had during this process. By the end of it, I was kind of proud of what I built. At various parts in the middle, I regretted ever starting the project and things like that. A lot of that was to do with, I guess, my unfamiliarity with step functions. I think I'd only ever made maybe one before, and it was kind of a toy example, not kind of something that needed to be super secure and whatnot. But yeah, the IAM policies probably burnt the most amount of my time. If you're just doing general allow and of specific actions, or maybe on resource names, it's not too bad. But once you start going into conditional tags and conditional allows based on various context keys, it becomes really difficult. There's no way to really see the full context keys that come along with a request, because obviously CloudTrail only shows you so much. So I burnt a boatload of time there, but eventually got there. And something else I found difficult, given this was an extremely long-running step function that I need to restart a lot of times, I wasn't able to find a way to resume the step function from a failed spot, that kind of thing. I did eventually speak to Steve Leedig, so some of you guys might know him. He's kind of the serverless expert at AWS, and he gave me some tips on potentially different approaches I could have taken to have helped with that. I won't go through them here, but definitely hit up AWS if you want to get some advice on that. And again, yeah, we tripped ourselves up with the default RDS encryption key. So if you learn nothing else from today, if you're spinning up a production RDS instance, just throw a customer managed key on it straight away. Even if you don't necessarily have plans now, it will obviously make things easier for you down the track. We're kind of lucky we did a migration to Aurora at some point, and during that kind of migration gave us the opportunity to switch out the key, so we no longer have to do that extra copy. But obviously, replacing your entire RDS database with an encryption key is a huge expensive operation, so if you can avoid that up front, definitely do that. And the last thing that I burnt quite a lot of time on was fiddling around with session manager and run commands. So because the sanitization script could run from anywhere between an hour to sort of 3 hours, I needed to set much bigger timeouts on those, the run command calls. It wasn't particularly well documented, and I kind of beat my head against the wall for several hours on this, eventually opened up an AWS support ticket, and after some back and forth over about a day or two, we got it figured out, but that was probably the only other painful part of the process. To finish off, yeah, this is kind of a list of improvements that I'd probably make if I did more work on it, and I probably will at some point do some of it. So the first one there is to just have this scheduled to run maybe every week. So every week, developers or whatever can come in, get a nice fresh copy of the database and do whatever testing they want. Second, just have a bit more, I guess, monitoring and alerting about what's happening, so we know if it's being run, we know what part of the process it's at, if it fails, that kind of thing. I mentioned before, putting all the temporary resources in a separate VPC just to give that extra layer of isolation, but ultimately I still haven't really kind of decided whether that's worth the extra complexity or not. And a few other bits and pieces like, yeah, potentially open sourcing it at some point just so I can become a GitHub superstar. But yeah, that's pretty much all I had for today. Thanks very much. One small, I guess, plug for VGW. We are currently hiring, so if you do want to come work with incompetent engineers like me, definitely hit me up after this and I'll hook you up. And yeah, thanks very much, guys. It's been a pleasure.